Hello everybody, welcome to the Henstitute Lab. We're going to take a look at the last part of the Behavior of Gases lab. This one is on Gay-Lussac's law, otherwise known as Amontons law. So it's going to look at how pressure and temperature are related to each other. If you notice on each one of these, I have a little picture on there that I want you to kind of show a graph of what you think the relationship is going to be between these different concepts. So one of the things before you actually start this, I want you to kind of think about what you think the relationship between pressure and temperature is, and put that into your picture before we actually get a graph. We're going to be using this equipment over here. So we're going to be using the gas pressure sensor again, but this is going to be a little bit different. We're going to have it connected to this Erlenmeyer flask with the setup rather than that setup that we had before. So this is going to be our gas that we're going to use. We also need a temperature probe, so we're going to be using that. And then we're going to have these sitting in this hot water bath. So we're going to have this sitting in here, and then we're going to have the temperature probe like that. And that's how we're going to collect our data. Now, before I can actually collect it, I'm going to do a little change on our graph here. Normally, we always do time-based. So in other words, I have this set up. I'm going to see if I can bring this over a little bit closer. And you should see that I have it's pressure versus time and temperature versus time. But I'm going to switch this up. So I clicked on experiment and data collection. I'm going to switch this from time-based to selected events. And then I'm just going to click done. So now it says pressure versus event number and temperature versus event number. But I'm not going to leave it that way. I'm actually going to change it so that each one is graphed versus the other. But what selected events does is it doesn't constantly collect that data. What it does is it waits until you actually click keep before it actually collects the data. So that's one of the things I'm going to do. So switch this over. I'm going to make this pressure versus temperature and make the other one temperature versus pressure. So that's going to give us our nice little setup. So the first part of this is we're going to see if we can actually get this flask of air. We're going to have it actually kind of expanding and changing the pressure. So to do that, I need to get a hot water bath. So I'm going to pause for a second. I'll come back and add that hot water. Okay, I'm back. I'm going to kind of focus on this. So I've got hot water. I'm going to put this with the pressure sensor in there. I'm going to hold it down, and then I'm going to take the temperature probe and put it inside there. I'm going to go ahead and hit collect on the computer, and I'm going to let the temperature and the pressure kind of equalize until they kind of come to a constant state. But one of the key things is I need to kind of hold this down because we had a couple of trials where all of a sudden the top of this popped off. So we don't want to lose any of that gas that's in there. So I'm just kind of holding this down. Looks like I'm kind of equalizing around 52 degrees Celsius, so I'm going to hit my keep button. Now what I'm going to do is I'm going to pour off a little bit of the water and add some colder water. So I have found the easiest way to do this is actually kind of pour off a little bit into a styrofoam cup. So I'm going to pour off a little bit of this water into a styrofoam cup. And then I'm going to add a little bit of room temperature water. So what that's doing is that's changing the temperature. Now my temperature is dropping down to around 45 degrees Celsius. Looks like I'm staying pretty stable. I'm going to hit keep. Then I'm going to do the exact same thing again. I've got a cup here. I'm going to pour some of my warm water in there. Pouring off some of the warm water. Pour in some room temperature water. See what happens. We're getting into the 30s for degrees Celsius now. I'm going to keep this data. I'm going to do this same thing again. This is not the easiest to do all by yourself, so I'm just kind of doing my best. Try to collect as much data as I can for you. A little more room temperature water. So it didn't drop the temperature too much. So what I'm going to try to do is I'm going to try to see if I can pour off even more of this water. And then over here, I actually have a cup of ice. So I'm going to see if I can pour in a little bit of this cooler ice water, and then pour a little bit of my room temperature water back in there. See if I can get it to cool off a little bit more. So now I've got it into the 20s. That seemed to work pretty good. I'm going to keep that data. And basically, I'm just going to keep going. I'm going to just kind of keep cooling things off and collect my data. So the idea is I'm changing the temperature, I'm dropping the temperature and measuring the pressure. So I'm going to pause for a second until I finish this out. So I'm just going to show you one last little thing. On the computer, I've collected all my data. I'm going to go ahead and hit stop. So I feel like I have 6 good data points here, but everything's kind of scrunched together. So I'm going to actually auto scale these 2 graphs. There's the bottom one, it kind of spreads out. There's the top one, it kind of spreads out. What I'm going to actually send you is the temperature and pressure data. And what I want you to do when you make this graph is I want you to put temperature on the y-axis and pressure on the x-axis. And the reason why is we're going to use that to try to figure out what absolute zero is. I know if this is truly linear, when I have a pressure of 0, it should be at absolute 0. So if you look at the data now and I kind of compare things, I know things don't end up, but eventually what we're going to do is we're going to do a nice little linear fit here. You're not going to do it with Logger Pro, you're going to do this with Google Sheets and use that to try to figure out what absolute 0 is. So that's kind of our plan, and that finishes out the Gay-Lussac's law. Hope you enjoyed.